Hey, class, we kind of got interrupted there at the end of 3.1. So I'm hoping it's going to work right now. We'll check it out here in a moment. But we end section 3.1 with, let's see here, this is a moment of truth. Sweet. Relationships between the graphs of f and f prime being the derivative. So the important thing here, and some students really struggle with this, so make sure you kind of really focus on what we're about to do. Graphing these guys can be really tough. But we're going to be given the graph of f in each one of these two examples here. Okay, and we're going to just say we have a x and a y and an x-axis. And this graph here is the graph of f. Okay, and we're going to graph f prime. So one of the most important things you need to do is make sure you label your graphs. Now, in able to draw the graph of f prime, or the derivative, we need to remember that the derivative is simply the slopes, right? The slope of the tangent line. So if we kind of look at our graph right here, and I know I don't have like the nice little grid here, okay? But I think you kind of have it in your notes, okay? The slope of this little piece here, believe it or not, is -1. The slope right here of this piece right here, m, is equal to -3/2. Okay, right? Both negative slopes, obviously. I think it's a little bit obvious right here. Ooh, let's get that Bob Marley off of there. Okay, is m is equal to 0. And then my last slope here is up 2/1, so that'd be a slope of m equals 2. So how do I graph this bad boy? Let's go ahead, and those are my slopes in red. Yeah, I'll just go ahead and make it the same color. Okay, so if I wanted to go ahead and graph f prime, these slopes here are -1. So I'm just going to go down here. Let's say that's -1 right here. And I'm going to have an open circle there because we're going to learn later that if we have these little corners, that the derivative actually does not exist. And my graph right there, that would be f prime, okay, for those specific x values in terms of the derivative graph. This would be m is equal to, what is that, -3/2. So I would go here. Let's say that that's -2. So if I wanted to draw this next little piece of graph, it'd be -1.5. So it'd kind of go from there all the way to there, right? Once again, at those corners, we say the derivative doesn't exist, and thus that is why it's open at those n values there. Here we go. Here's a slope of 0. Where would 0 be? Smack dab right there, and from there to there. So I got a little graph right there. So all of these horizontal lines are the graph of the derivative. Okay, or the graph of the tangents, right? And then last would be up 2/1. So if we go here, I'm sorry if it's gonna, but there's, let's say 1, there says 2. So I come up here, open circle there, because it's one endpoint, it's a little corner. We'll find out later why it doesn't exist, and smack dab there, that's still all f prime. Okay, now what I challenge you guys all to do is hit pause on that bad boy button. Okay, and then what I want you to do is take a stab at the next one. Okay, I'm going to go ahead and get it started right now. I really hope you guys are challenging yourselves and you're going to try to do it on your own. This one's a little bit tougher. Okay, hopefully you tried it. Hopefully you have something a little bit like this. I like to, this one's a little bit easier because it's just like smack dab straight lines, right? This one and the second one, it's a curve. So what I like to do is say, hey, do we have any zero slopes anywhere? Because if we have any zero slopes on the graph of f, this being the graph of f, then that means on f prime, or the derivative, the answer would be 0. So I'm going to be 0 right here. Now, if I just look very carefully, okay, I'm going to inspect, and you know what, let's make it a little bit different color. I'm going to make it blue. These would be very, very high positive slopes. And as I get closer and closer to that horizontal slope, or the horizontal tangent of 0, if you notice, there's still positive slopes, right? Those tangent lines are still positive, but they kind of level off, right? It's a smaller and smaller positive number. Vice versa, kind of like a roller coaster. As I come this way, those are all negative slopes. But the further I go down, whoa, does it get to be a really high negative answer. So believe it or not, the graph of the derivative is going to look like this. This right here would be a very high positive, so it would be like way up there. Okay, this guy here, and they kind of just keep on coming down. This one right here would maybe be about right there. Okay, that'd be a little positive number, but it would be right here. This would be a negative number, but it'd probably be right here. This would be a huge negative number, be down here. Believe it or not, it makes this straight line. Kind of crazy, right? But we want to make sure we label whenever we put two graphs on the same line. Okay? All right, now if you're a little bit confusing, class, and this can be pretty rough for some people if it's the first time doing it, going from the original graph right here to the derivative graph, check out this sweet little video here, and Khan Academy can be so helpful for getting other resources that can really help you out. All right, class, now let's get a little bit crazy, and like anything in math, it's always good to go forwards and then go backwards. All right, so here we go. Now we get the graph of f prime of x. Whoa, and I got to go backwards. So this is f prime. Well, what does that mean? That means the slope of the original graph is -1 for that entire piece. And guess what it means? This is f prime again, right? So, ooh, it's up, it's 2. So that means m equals 2. And once again, so this would be slope of -1 on the original graph, and this would be a slope of +2 on the original graph. So how the heck am I supposed to draw an original graph? Well, here we go. I drew that kind of in red right there. So I'm going to go ahead and draw the rest of this graph in blue. And they give me some really important pieces of information here. They tell me that on the original graph of f, I have the point 0, 2. So guess what? I can go bang, bang, choo-choo train, and I can make a point right there because that's actually on that graph. And guess what? I needed that because if I didn't have that, this graph could have been anywhere on the coordinate plane. Okay, but since I have that, I can kind of work off that a little bit. Now, if I look very carefully, it says the slope of the original graph, and I'm going to draw the original graph here. We'll call the original graph f. The slopes before x equals 1 is -1, which would be down 1 over 1. And I got to put an open circle there because I don't know what's going on there, right? I don't know if that's filled in or not. The only point I really know on that guy for certain is this one right here. Okay, but right there at that value, I'm not quite sure if it's defined there or not. And we all learned way back in the day when we took Algebra 1 that we could go down 1 to the right one, or what could we do? We could go up 1 and to the left one. Up 1 and to the left one, right? Because all those slopes are -1. So guess what? F is going to look like that bad boy right there. But at x equals 1, something interesting happens. Okay, the slope changes from -1 to a +2. So what am I going to do from that guy? Up 2 over 1. Up 2 over 1. And I get a graph that looks like that. Pretty darn cool, right? But I'm telling you right now, class, real difficulty always happens on changing these graphs to f prime to f or f to f prime. Make sure you practice it. If something wasn't good, go back, try it again and again, or make sure you rewind and watch the video again. Okay, here we go. Let's finish section 3.1 with example 6. I love this example because this is going to help you guys out. It's a big piece of our calculus moving forward. One of the most important things whenever you are given a graph is you circle 3, 4, 5, 6, 7, 8, 9 times, whatever you are looking at, and don't lose focus of that. Now, we're going to use what we call sign analysis quite a bit in this class, okay? And I'm going to go ahead and get it started right now. Maybe probably a little bit early, but that's okay. You guys seem super smart, so we can do that. So what is sign analysis? Well, I'm going to do sign analysis for the first derivative. That's why I'm labeling this particular sign analysis as h prime. Okay? And then what I'm going to do is I'm going to use my graph to help me out. And whenever I do sign analysis, it really helps to simplify some things. All right? Now, what do we put on our sign analysis? We like to put whenever we have zeros. So since h prime is 0 at -2 and 2, I'm going to go ahead and do that right there. Okay, and then I'm going to write on my sign analysis what's happening with my graph. If you look here, before I get to -2, all of my values are negative. So I'm just going to put a negative sign right there. Okay, from -2 to 2, if you look, it's always above. So if it's always above, class, my pen ran out. So here we go. Let's go to some stylus time, and hopefully it works a little bit better this time. Okay, they're all positive. And then, okay, those are all that from -2 to 2. From 2 on, all of my slopes are negative. Okay, class, now I'm going to try this again. Let's hope it works because I'm not redoing this bad boy. Okay, what is the value of h prime of 0? Okay, well, the value of h prime of 0 would be whatever the output value is on that graph. That would be h prime of 0 right there. And we're going to write that h prime of 0 is equal to 4. Okay, if h prime of 0 is equal to 4, what does it tell us about h of x? Well, remember, the derivative graph will always tell us information about the original graph, h. And it tells us that h of x at x equals 0 has a slope of 4. Okay, you guys do a little bit job of taking notes. I would have written it all up there, but it's kind of hard to put it right here on this graph, okay? So I apologize for that. Okay, using the graph of h prime, so once again, coming over here, using this bad boy right here, how can we determine when the graph of h of x is going up or going down? So once again, this information, this sign analysis, which was huge, answers all those things for us. So believe it or not, when h prime of x is greater than 0, we know that h of x is going up, okay? And we know when h prime of x is less than 0, h of x is going down. So you know what's awesome about the sign analysis? We have the answers right there for that, okay? Which means from negative infinity to negative 2, here, I'll see if I can fill it in right here. Okay, so from negative infinity to negative 2 union 2 to infinity, h of x, the original graph, is going down or decreasing. Okay, and then from negative 2 to 2, okay, we say that h of x, the original graph, is going up. And I was able to do that just by my sign analysis, which really helps us to simplify some things. All right, now see, the graph of h prime of x crosses the x-axis at x equals 2 and x equals negative 2. Describe the behavior of the graph of h of x at these points. Well, hopefully we know, you know what, at h prime of negative 2 is equal to 0. How did we know that? Well, smack dab right there, it's 0. And h prime of 2 is equal to 0 because it's right there. So remember that when a slope is 0, we say that it has a horizontal tangent. Has a horizontal tangent right there. Why? Because it has a slope of 0. And the other important thing it tells us is that if you look at each one of those zeros, so here at negative 2, remember, if we look back at our sign analysis, it went from negative to positive. So the original graph will change from decreasing to increasing, or will be going down, and then at negative 2, it will start going up. So here, look over here at the side. So my graph's going to kind of go down, but then it's going to go up. It's a horizontal tangent. And this is what the original graph would kind of look like. I know it's all over the place, you guys. I really apologize. We'll make sure we clear it up super duper duper in class, and I get this pen situation figured out. Thanks so much. Hopefully 3-1 was good. Remember, you should always be doing the worksheets that we didn't finish at home. Aloha.